Hello friends, today we are going to talk about cotter joint. A cotter joint is used to connect two coaxial rods which are subjected to either tensile or axial forces. In a cotter joint, there are three things which is like first one is socket, second is cotter, third is spigot, which is mentioned here. See how a cotter joint is fixed. These are two rods. These are two rods by which the socket and spigot is connected, and then spigot enters into the socket and cotter is fixed inside it, so that it provides complete action of flow of axial and tensile forces. So coming on to how to design a cotter joint. To design a cotter joint, see in the numerical, suppose the question is that a force of 60 kilonewton is being applied. A force of 60 kilonewton is being applied. So if the material is given to you, you have to directly consider it from the design data book. If it is not given to you in the problem, what you have to do is you have to assume that it is plain carbon steel. It is plain carbon steel made of 30C8 whose sigma YT is 400 megapascal. Yield of tensile strength. Okay, this is 400 megapascal. This is what we have to consider. Now I have told you, since there are three things, four. A rod which are connecting it, and rod, socket, spigot and cotter. Okay, so we need to consider those tensile, compressive and shear stresses acting. These will be the three forces which will be acting on a cotter. Let us consider those points. See, for rod, socket, spigot. Okay, for rod, socket and spigot, what are the forces which will be acting? Rod will be having tensile force, compression force as well as shear force. Same for socket also, tensile force, compressive force, and there will be a shear. And see, similarly in the spigot also. In cotter, there will be two forces, tensile and shear. I'll explain you how it will be acting on it later in the discussion. See, sigma T is nothing but sigma yield upon factor of safety. It is sigma yield compression upon factor of safety. Shear force is tau yield upon factor of safety. Sigma T is sigma yield upon factor of safety. Shear is tau yield upon factor of safety. Okay. For rod, socket and spigot, if factor of safety is mentioned in the numerical, you have to directly take it from there. If it is not mentioned, we have to take it as 6. And for cotter, we have to take it as 4. I have told you sigma YT is 400 megapascal. So, sigma yield upon factor of safety, it will be 400 upon 6. This will be sigma YC. What is sigma yield compression? Sigma yield compression is nothing but 2 times of sigma YT upon factor of safety. This is nothing but 2 into 400 upon 6. Yield, tau yield is 0.5 times sigma YT upon factor of safety. So it will be 0.5 into 400 by 6. Okay. For tension in cotter, sigma T in cotter, 400 upon 4, right? Tau y 0.5 times sigma y T upon factor of safety, right? 0.5 into 400 upon 4. Okay, we will get the values like 66.67 MPa, megapascal. Always remember the unit. This will be 133.34. Tau yield 66.67 by 2. It will be your 33.34. This will be 100 megapascal. This will be your 50 megapascal. Okay. So these are your tension, compression and shear on rod, socket and spigot whose factor of safety is 6. For cotter, factor of safety is 4 and tension and shear stresses are acting over it. Okay. Coming on to the design. Till here we have mentioned everything. Now we have to design the cotter. I'll rub it. Okay. For designing a cotter, first I need to design the diameter of the rod. So first point is to design the diameter. First, dia of rod. For the diameter of the rod, it will be, what is the force acting on the rod? Tension or compression. So sigma T equal to, what is it? How is the force acting over it? See, this is the rod. Force is acting in this direction. This is your P. So P which I have mentioned like it was 60 kilonewton. Let us assume that. Okay. 60 kilonewton P is acting here. This is your P. Okay. So what will the tension force over it? Tension force will be P upon area, right? P is your 60 into 10 power 3 upon pi by 4 into d square. What is d? D is the diameter of the rod. Diameter of the rod is d. Okay, just note down what are the nomenclature I am giving. Okay, it might be confusing. So sigma T equal to P upon A, 60 into 10 power 3 upon y 10 power 3 kilonewton to newton upon pi by 4 d square. Sigma T is what? Sigma T I have just calculated right now for rod was 66.67. Okay, so from here you will calculate the diameter. What will be the diameter now? After calculation, the diameter will be 33 point some decimal places. I have rounded out to 34 mm. Since I am designing, for me, what is better? A decimal place or something larger from that which can hold it. So some value like 33 point something I was getting. So I rounded it off to 34 mm. So this is the diameter of the rod. Now, coming on to some of the other nomenclatures. Okay. Don't get afraid. I'll be explaining it to you. Okay. See, now I have calculated the diameter of the rod. This was the rod on which P force was acting. See, rod and the P force was acting here. Okay. And I calculate the diameter. Second step is to calculate the thickness. What thickness I am talking about? This thickness. This is the front view I am telling you. See, what is the thickness? This thickness I am talking about, in which the cotter will be fit. This thickness. This will be the same. It will be the same for spigot, for socket and for the cotter. This thickness I am talking about. This thickness directly will be taking it as, this thickness I am naming it as T. I am naming it as T, and this is directly equal to 0.31 times D. So 0.31 into 34. What is the D? D is diameter of rod. This is 10.54 or something. I have rounded it off to 11 mm. Okay. So I have calculated T, that is thickness. Thickness of what? Thickness of that cross section. Thickness of this cross section is T. Okay. Next one is to calculate. See, now I have calculated diameter of the rod. Next thing is to calculate the diameter of the spigot. I will take diameter of the spigot as D2. Okay. Second, dia of spigot. Diameter of spigot. See, again I will take what is the force acting on it. What I will think is what is the force acting over it. I will take tension force. Okay. Sigma T equal to. Now coming on to the diagram. This is the spigot. Okay, which will be fitting inside the socket. See. Now here, what is the cross section on which the force will be acting? Diameter of the spigot, I will be taking it as D2. Okay. So what is the sigma T equal to P upon area? P upon area. What will be the area of the cross section? This diameter is D2, to pi by 4 D2 square minus this cross section. This is what? This is the thickness. So what it will be? D2 into thickness. This D2 into this thickness, because there is nothing there, only the cross section over this P load is acting in a spigot is D2 into T. So what will be my area? My area will be P is 60 into 10 power 3 upon pi by 4 D2 square minus D2 into T. You got it? This is the area of the cross section. I'll again explain it to you. Pi by 4 D2 square complete cross section, but there was nothing here. So D2 into T is being subtracted from there. You know T, you don't know D2. You will get a quadratic equation. Yeah, sigma T, same 66.67. So what you will do, you will get everything. Since here it is in megapascal, so everything will come in mm. Okay, take care of the units. So D2, I'll get a quadratic equation in form of D2, and after solving, value of D2 will be 41.57, which is equivalent to 42 mm. Third, dia of socket. Diameter of the socket, I'll be assuming that it is D1. Okay, it is D1. So load will be similarly for diameter. What is the force acting over it? Sigma T, okay, equal to P upon area. P, you know, 60 into 10 power 3, right? Area. So P upon area. What will be your area? Again, let us come to the diagram. This is your socket, right? This is your socket. This is the diameter of the spigot where the spigot will be entering, right? So this will be the diagram. Yeah, this diameter is D2, right? Yes. This diameter is your D1, which I have taken diameter of the socket as D1. So what will be the area? Pi by 4 D1 square minus D2 square, because it is hollow. Pi by 4 D1 square minus D2 square. But You don't have material here. So what will be the cross section? d1 minus d2 into t, which will be again subtracted from that area. This 60 into 10 power 3 upon area pi by 4 d1 square minus d2 square. Okay, minus d1 minus d2 into t, d1 minus d2 into t. Okay, what you know here is, you know d2, you know t. You will again get a quadratic equation in terms of d1, and that diameter after calculation is 55.6 something. Okay, so I'll just round it off to 56 mm. Next is d3, d4, a and c. I'll explain you what is it and how we are getting. Directly, this is 1.5 times d, this is 2.4 times d, and c are equal, that is equal to 0.75 times d. What is d3, d4? Don't panic, I will be explaining it to you. So d3 is 1.5 d, you know d, so the values will be 51 mm, 82 mm, and value of a and c is 26 mm. Okay, what is d3? d3 is nothing but diameter of the spigot collar. Here, there is no use, but still I am telling you. d4, d4 is the complete diameter. This diameter, complete diameter is your d4 that I have calculated. Complete diameter of what? Socket. For socket, the complete diameter is your d4. Okay, so now a and c. What is a and what is c? C is this distance of the, what is this outer portion is your socket, that distance. After that hole where we are inserting the cotter, after that the distance is c. What is a? A is the distance after that hole where cotter is inserted. Here it is a. Yeah, I'll explain you, it will be more clear there. This is your spigot. See, since a tension force is acting in a spigot, a load will be acting on this side with P force. This portion is your A. And for socket, this portion, this length is your C. Okay, this portion is your C. So that I have calculated. I have explained you what are the nomenclature. Okay, now let us go on to calculating the width of the cotter. Now I want to calculate this length. I need to calculate. What is the force acting in a cotter? See, for a cotter, since they both are having tension forces, this will be shearing. The cotter will be shearing. See, when the forces are acting like this, the cotter tends to shear at its surface, right? So I will be using that shear force for it. So shear force equal to P upon that area where it will be shearing, right? So let us assume that width of the cotter is B. This width is B, right? So what it would be? 2 into B into T. This is nothing but the shear area. B into T. T is the thickness. Above the thickness, this T is your thickness into T. Because at both sides, 2 why 2? Because at both sides that shear force will be acting. So B into T. From here, you know T, 0.31 into D. You don't know. You have to find out B. you know P. Shear stress for cotter I have already calculated, which is nothing but 50 megapascal, which I have already calculated. This is 50. Okay. You don't know B, you know 60 to 10 power 3. This is T, you know everything. From here, you will get the value of B. What is B? B is the width of the cotter. This width of the cotter is B, and its value is 55 mm. So its value is your 55 mm. Now coming on to checking whether these calculations for me is correct or not. Now to check it, I'll rub everything. Now whatever I have designed, I have given you all the data for which a cotter can be designed. So whether the design is safe or not, that is what now I have to check. For that, checking shear stress and crushing stress in check shear and crushing stress in first case spigot. So I'll be checking shear and crushing stress in spigot. First we'll take shear stress. Shear stress in the spigot. What will be the shear force acting in the spigot? P upon area of the shear, right? That area of the shear is nothing but See, here is where the shear action is taking place. This cross section and the opposite cross section there, that will be A into D2 into 2. See how it is? See, force is acting on a spigot like this. Similarly, for this A cross section, a shear will be acting on it. What will be the area of the cross section? D2 into A. 2 into A D2. This is 60 into 10 power 3 upon 2 into A into D2. A is 26 into 42. I have already calculated it. Okay. So this will be my shear force for the spigot, and its value I am getting is 27.47. 27.47 megapascal, because all these values are in mm and this is in Newton. Okay. So I am getting shear force in a spigot is 27.47. But what I have calculated in my earlier calculations, that shear force in a spigot is nothing but 33.34 megapascal, right? So this value is less than 33.34 megapascal for this my spigot. So it is safe. Till now it is safe. But now I have to check the crushing stress too. So checking the crushing stress. Sigma C. I will be mentioning crushing stress as sigma C. Sigma C equal to where the crushing action will be taking place. Where it will be crushing? It will be crushing at this cross section. It will be crushing here, right? So what is it? This thickness is T into D2. This is the diameter. It will be shown here. No. Okay. This thickness into D2. So that will be P upon this thickness T into diameter D2. That is equal to 60 into 10 power 3 upon T. Thickness you are knowing, diameter you are knowing, 42 into 11. The value which you are getting is 129.87. and it is less than what I have calculated for spigot crushing stress was 133.34 megapascal. Sorry. So for my calculation for spigot is correct. It will not fail. My spigot will not fail. Similarly, now I have to check it for socket to socket. What will be my area? See, for socket, sigma shear stress is equal to P upon area of shear. Right? So what is my area of shear? Area of shear will be this length, right, into d4 minus d2 into 2, because the shear force will be acting on both sides. See, d4 is my outer diameter, total outer diameter, d4 minus d2 into c into 2. That is 60 into 10 power 3 upon 2 into c d4 minus d2. Okay, you know the value of c, you know d4, you know d2. Now shear force, which is the value of shear force which I am getting is 28.846. mm. Sorry, not mm. It is megapascal. Okay, so this is the value of shear force which I am getting for a socket, and shear force which I have calculated was 33.34 for ideal cases, which is less than 33.34. So shear force is okay, fine. Coming on to crushing force. For crushing force, where will be the crushing action happening? This side. What is this? What is the cross section where shear force is acting? This d4 minus d2 into t, right? This d4 minus d2 into t will be the where crushing force will be acting. P upon d4 minus d2 into t, right? So P will be 16 to 10 power 3. d4, d2 you have already calculated. d2 is your thickness, diameter of the spigot. Thickness you have already calculated. So what value I got was 130 MPa, 133.34 megapascal, which I have calculated in ideal cases. So my design for socket is also safe.